I do love my Home Assistant setup, which is basically just a Raspberry Pi sitting in my home's distribution box that runs the Home Assistant software. But by integrating smart devices like my PV system, heating system, outlets, thermostats and blinds, I can not only see from everywhere in the world what is going on in my home, but I can also control everything and automate everything if I want to. That is pretty awesome. Only problem is that I'm not alone in this household, and my girlfriend does not really want to use the Home Assistant app. That is why she's using Alexa and voice commands to interact with outlets and blinds, which does work for most of the time. But sometimes Alexa randomly disconnects from the internet or simply refuses to do its thing. And that got me thinking whether it is possible nowadays to use some kind of microcontroller and microphone to create a more reliable voice assistant alternative. So in this video I will try to do just that, and hopefully will not have to spend 2 days trying to compile some code that will ultimately never work. Let's get started! If you're working on a signal-dense PCB, like a high-speed digital circuit, then 6 layers can really simplify your layout. Which brings me to the sponsor of this video, JLCPCB. They of course offer 6-layer PCBs with super fast lead times, flexible design options, and like always, really high quality. They've also recently added support for blind slots, which can help dissipate heat more efficiently in high power or high frequency applications. So click the link below to get a $30 coupon and try this new feature in your next multi-layer prototype. Now to get started, I firstly wanted to get a grasp on how an audio waveform that looks like this can get recognized by a microcontroller. I mean, can you spot the difference between these two waveforms here? Because they are two completely different words. So I did a bit of research, and as it turns out, microcontrollers do not directly use such waveforms. Instead they use so-called MFCC, which stands for Mel Frequency Capsular Coefficients, which could look something like this. To get to this result, the microcontroller firstly applies an FFT, which I can also do here on the oscilloscope, in order to turn our original amplitude over time waveform into a magnitude over frequency one, meaning we can now see what frequencies are mostly in there. Then the microcontroller applies filters to mimic what a human would hear, and another complicated sounding transform, to ultimately end up with the coefficients that apparently contain all the essentials of human speech. These then get compared to a neural network, which is similar to the one I created myself in a previous video. There I took tons of pictures of my corridor and labeled them as blocked for my robot, and thus by comparing those to its live camera feeds, the robot drove around on its own without hitting any walls. Now of course, the voice command neural network does not come with pictures, but instead with tons of MFCC that all represent different words, and if one is similar to our MFCC turned audio waveform, then we know what word or phrase got spoken. So long story short, voice recognition is not only complicated, but for it we also need a fast and powerful microcontroller to do all the MFCC stuff, and also a pre-made voice-trained neural network. So I dug through the internet once again to find a more or less pre-made solution. And I think I found a promising one in the form of ESP-Skainet. Now I chose this one not only because I think the name is funny, but also because I love using the ESP microcontrollers. And for this kind of project, they recommend the ESP32S3, because it features additional support for vector instructions, which apparently accelerates the neural network tasks. So I of course got myself such an ESP board, along with an I2S microphone, I2S audio amp with small speaker, and an LED ring light, because it looks kind of awesome for user feedback. But at this point I had no idea how to put all the components together, and let's just say that the given ESP-Skainet code did not really help with that. I mean, uploading it via the Arduino IDE was not possible at all, and thus I had to install the ESP-IDF extension in Visual Studio Code. There, however, I could not compile the code no matter what I tried, only to eventually realize that the newest version of ESP-IDF is not compatible with their own code, and thus I had to use an older version. But even with that, nothing really worked, and thus, like I spoiled before, after 2 days of getting nowhere, I aborted this mission. So instead, I got myself this board here, which is a voice recognition module that is not too expensive, I would say. This is basically a complete pre-made solution that we can connect to a microcontroller using the I2C interface. And best of, it comes with an Arduino library, which after installing and uploading the I2C example code to my ESP board, seems to work just fine. Now to use the voice recognition, we are given a list with not only pre-programmed command words, but also most importantly the wake up words, which does exactly what you think. Hello robot.
Yes, I'm here.
And after the wake up words, we can say commands like turn on the lights.
Okay.
This triggers a response from the module to the microcontroller that we can see over the serial monitor. And these ID numbers here basically correspond not only with the command, but also the wake up words. So by using those IDs, we can tell the microcontroller to do different things, like lighting up my LED ring, which, as you can see, works perfectly fine. Hello robot.
Yes, I'm here.
Turn on the lights.
Okay.
Now of course, I did some more testing afterwards, and I gotta say that it works pretty reliably, and you can even record custom commands, meaning this module is a good fit for all kinds of electronics projects. But the next question is how to let the system talk to HomeAssistant. And I think the easiest way would be by sending out MQTT messages. Only problem is that whenever I add a new device, I have to manually redo code on the ESP and HomeAssistant side, which makes such a setup just too cumbersome. So instead, it would be great if the ESP would directly send over the voice commands, and HomeAssistant then evaluates them and decides what to do. And as it turns out, that is actually possible, because HomeAssistant does come with a voice assistant feature that you simply have to activate. And the great thing here is that many languages are supported, and not only English like before. So I firstly tried it out with my smartphone as the microphone, and it not only seems to work just fine, but many pre-made useful commands are already there, and you can even make your own with a bit of automation. And best of all, ESP Home does support this voice assistant feature as well. And in case you forgot, ESP Home is an add-on in HomeAssistant that can be used to turn your ESP microcontrollers into smart devices, like a water level sensor here. The only question now left was how to properly configure my ESP Home device, because there are many variables. Before doing that though, I connected the ESP32S3 to computer in order to flash the blank ESP Home firmware onto it. And then I had a look at similar projects, where the configuration sadly did not work for me though. However, after a bit of tweaking things, the code compiled just fine. And after uploading that, and hooking up all my components to the ESP32 like shown here, everything seems to work just fine. Listen. Hey Jarvis, turn on battery heat.
Turned on the switch.
So time to end this project by 3D printing a nice enclosure for it all that I designed myself. And I gotta say that I really like the multicolor here, but before gazing at it too long, I glued all components onto the front and added a USB-C jack inside to power everything. Afterwards, I repeated all the wiring from before. And yes, I will certainly not win a beauty competition here, but what is important for me is that everything works just fine. And just like that, I got my Alexa alternative, which seems to do its job pretty well. And I think the LED ring is a true highlight. But of course, only time will tell which one of these two systems will work more reliably. So stay tuned for future updates. So far I love, however, how customizable this solution is. And I hope you learned something new through my trials and errors. And maybe try voice recognition on your own in the future. If so, consider supporting this show on Patreon to keep it going. And like always, don't forget to like, share, subscribe and hit the notification bell. Stay creative and I will see you next time.